Hello my dear students, how are you all doing? I hope you all are fine. I would like to inform you all that I'll be starting online video sessions on chemistry for all the sections of class 8. The videos will be uploaded on middle school YouTube channel. Therefore, please do subscribe the channel to get the latest notifications. This session is all about the different theories that describes the structure of an atom. That is number 1, Dalton's atomic theory, number 2, J.J. Thomson's atomic theory, and number 3, Rutherford's atomic theory. The first two theories we have already covered in the school itself, so we are going to concentrate only on Rutherford's atomic theory, which is mentioned in page number 61 to 63 of your textbook. Before we go into the details of Rutherford's atomic theory, it is very important for us to recall some important terms related to atom. We all know that an atom is the smallest particle of a matter and it contains three subparticles, that is electrons, protons and neutrons. Electrons are negatively charged. They are found in the cells or orbits of an atom and they revolve around the nucleus. Protons and neutrons are found in the nucleus of an atom, and protons and neutrons together in the nucleus of an atom are collectively called nucleons. Nucleons. Since the only positively charged particles present in the nucleus are protons, the net charge on the nucleus will be positive. If the number of protons is equal to the number of electrons in an atom, the net charge on an atom will be 0. Hence, an atom is said electrically neutral. Now, let's quickly summarize these important terms related to atom. That is, number 1, nucleus contains protons and neutrons, collectively called nucleons. Neutrons do not carry any charge. Protons are positively charged. Electrons are negatively charged. A nucleus is a small entity with respect to an atom and it is centrally located. It is said that nucleus is hard and dense and the entire mass of an atom will be concentrated in the nucleus. And it is also said that most of the space in an atom is empty. Alright, now let's come to the main content, that is Rutherford's atomic theory. Rutherford performed an experiment which we today now know as Rutherford's gold foil experiment and is also called alpha particle scattering experiment. In this experiment, Rutherford took thin gold foil and bombarded alpha particles on it. These alpha particles were released from a radioactive substance called polonium. Then these alpha particles were made to pass through gold foil and were made to strike the zinc sulfide screen for detection. You need to keep it in your mind that alpha particles are positively charged. Just have a look at the diagram on the left hand side. You can see that on the left hand side there are small dots with positive sign in the center. These are alpha particles. On the right hand side you can see some circles which are shaded blue with a positive sign in the center. So these are representing the gold atoms. You must be wondering, out of all the metals, why did Rutherford use only gold? The answer to this is that since gold is one of the most malleable metal, it was very easy for Rutherford to hammer or beat gold into thin sheets for his experiment. After performing the experiment, Rutherford made some observations. And those observations were, number 1, most of the alpha particles passed straight through it. Here you can see in the diagram, the alpha particles are traveling straight, and once it comes close to the gold atom, it passes through the gold atom and it passes straight through it without any deflection. That was his first observation. Number two, very few alpha particles were deflected through some angles. You can see that these alpha particle is traveling in a straight line once it enters inside the gold atom and comes close to the periphery of this positively charged area, it is changing its path. That was his second observation. Third, very few alpha particles retrace their path. That means here you can see that if the alpha particles which are positively charged is traveling in a straight path, and once it enters inside the gold atom and it strikes the core of the gold atom, in such a case the alpha particles got bounced back into the same path from where it came. To these observations, Rutherford made these conclusions. Number one, most of the space in an atom is empty. You can see here that this alpha particle traveling straight, once it enters into the atom, it is passing straight through it. And most of these rays pass straight through the atoms of the gold. He concluded that the space in an atom is empty, most of the space. Number two, nucleus is positively charged because it repels the positively charged alpha particles. You can see that the alpha particles are positively charged. When it is released from polonium, it travels in a straight path, and when it is coming close to the proximity of the gold nucleus, you can see that it is changing its path. Why do you think that the alpha particle is changing its path? The answer is very simple. As I had told you in the previous slide only, that the net charge on the nucleus is positive and alpha particles are also positively charged, and when similar charges comes close to each other, you know that repulsion will take place, isn't it? This is the reason why some of the alpha particles which came close to the proximity of the center of the gold atom, which is positively charged, it got repelled and thus changed its path. The third conclusion, nucleus is hard and dense. Very few particles, almost 1 in 1000, it was noticed that when these alpha particles traveled in a straight line and was striking the core of the gold atom that is positively charged, it bounced back into the same path from where it came. Therefore, he gave a conclusion that nucleus is hard and dense. I hope